Hello dear students. In this lecture we will see the behavioral pattern and types of behavioral pattern. At the end of this lecture you will be able to introduce behavioral patterns and different types of behavioral design patterns. A behavioral design pattern are concerned with the algorithms and the assignment of responsibilities between the objects. Behavioral class patterns uses inheritance to distribute the behavior between the classes to distribute the responsibilities between the classes, whereas the behavioral object patterns use composition rather than the inheritance pattern. Some of the behavioral design patterns describe how a group of peer objects cooperate to perform a task that no single object can carry out by itself. So there is a teamwork of objects. Some of the examples of behavioral design patterns are command, iterator, observer, state, strategy, chain of responsibility pattern, and memento pattern. Let us see the command pattern. The command design pattern encapsulates a request in an object. It allows the parameterization of clients with different requests. The command pattern allows saving a request in a queue. A request is wrapped under an object as a command and passed to the evoker object. The evoker object, that is, the calling object, looks for the appropriate object which can handle this command and pass the command to that respective object which executes the command efficiently. For example, let us consider a table order at a restaurant. The waiter takes the order, which is a command from the customer. Then this order is then queued for the kitchen staff. The waiter tells the chef that a new order has come and the chef has enough information to cook the meal. Now here the chef is the right object to whom the command has been passed to complete the task. Let us see the observer pattern. It defines a one-to-many dependency between objects so that when one object changes the state, all its dependent objects are notified and updated automatically. Observer delegate the responsibility for monitoring for an event to a central object so that it can notify a verifying or varying list of objects that an event has occurred. For an example, let us consider a real-world example of an observer pattern that can be any social media platform such as Facebook. When a person updates his status, that status will be seen on the Facebook page and all the followers of that respective person gets the notification. That is the good example of observer pattern. Let us see the state pattern. It allows an object to alter its behavior when its internal state changes. We create the objects which represent various states and a context object whose behavior varies as its state object changes. Now let us take the example of a vending machine. Vending machine has state based on the inventory, amount of currency deposited, the ability to make the change and the item selected, etc. Now, when the currency is deposited and a selection is made, a vending machine will either deliver a product and there will be no change, or it will deliver a product and there will be a change in the state, or it will deliver no product due to insufficient currency on deposit, or deliver no product due to inventory duplication. So one object is dependent, the state of one object is dependent on the internal state of other objects, and the state of an object alter the alter its behavior when the internal state changes. Let us see the next pattern, that is strategy pattern. It defines a family of algorithms, encapsulate each one and make them interchangeable. The strategy lets the algorithm vary independently from the client that use it. It enables us to use the different tools or algorithms depending upon the context in which they occur. The strategy pattern separates the selection of algorithms from the implementation of the algorithm. A class behavior or its algorithm can change at runtime. Let us take a example of mode of transportation to an airport. Any of these modes of transportation will get a traveler to the airport and they can be used interchangeably. For example, a traveler can take a car to go to the airport. A traveler can take a bus to go to the airport. So any of the mode of the transportation will get the traveler to the airport and they can be used interchangeably. The traveler must choose the strategy based on the trade-offs, that is cost, convenience and time, etc. So likewise the strategy pattern, likewise the algorithms can be used as per the situation, environment and the implementation. The chain of responsibility pattern. The chain of responsibility pattern is used to achieve loose coupling in the software design, where a request from the client is passed to a chain of objects to process them. It creates a chain of receiver objects for a request. In this pattern, normally each receiver contains the reference to another receiver. If one object cannot handle the request, then it may pass the same to the next receiver and so on. Let us take the real time example. Now, for example, a student named as Sai has some difficulty or he is facing some problem. Then that student may come to the faculty. If faculty is able to solve his problem, then the problem will be solved over there. But if the faculty is not able to solve the problem, then uh, faculty will refer that student to the head of department, and then that request will be sent, the request will be passed to the next level. And in the same way, if the problem is not in the scope of head of department, then that matter will go to the director and so on. That is the chain of responsibility. Then the next pattern is iterator pattern. Iterator pattern is very commonly used design pattern in Java and .NET programming environments. The iterator pattern allows us to access the contents of a collection without exposing its internal structure in the sequential manner. It supports multiple simultaneous traversals of a collection. The iterator pattern provides a uniform interface for traversing different collections. For example, the MP3 player. Now, in the MP3 player, there are number of different songs. The basic forward and back button can be used to change the song by using the forward and backward button. So that can be compared as the iterator pattern. Compared with the iterator pattern, that is traversal can be go as forward and backward in that MP3 player to change the different song. So I hope you have understood the behavioral pattern and different types of behavioral pattern. In the next lecture we will see the creational pattern. Thank you. Happy learning.